All right, so here we go. We're going to sketch let's take a look at this. All right, so here we go. First thing, let's go ahead and put in our dashed line right here, right? This is where the curve's going to fall apart. That's where we're going to have the breaks, the dots. What does this look like? A V. But it's not your standard V from the origin. It's going to be Ving 2 to the right. And notice that it crosses the line right here in a solid dot. This tells me what to keep. So you've broken your V, snapped it in half. You're going to keep this piece, that piece, and you're going to get rid of this piece. All right. Then, what does this look like? Here's my tricky thing again. What does that look like? Upside down parabola. It hasn't been moved, so it's right here, right? Oh, you probably can't see. Can you see that? It's right there. It crosses here. That will be an open dot this time. And I'm going to keep, I'm going to keep, all my markers are running out. I'm going to keep this side of it and erase this side of it. Oh, that's a cool one. All right, take care of it. Mamuna?
Sorry, can we grab like a sign?
Yep. So we want to translate a sine function, so something like sine x plus 3. So I always start, and I recommend you do the same, by recalling what a regular sine looks like. So a regular sine looks like this. It comes up 1 and down 1. That's what a regular sine or cosine does. Up 1, down 1. What have we done to this picture though? We've moved it up 3. So instead of oscillating across the line where y is 0, it's now oscillating across this line. So instead of going up to 1 and down to -1, it's going to go up to 4 and down to 2. Everything is lifted up 3. So the top of the hill was at 1. The top of the hill is now at 4. It oscillates 3 steps up from where it was in the beginning. Okay, Mamuna? All right, who else? Who else can think of something that you might miss? Same thing with an exponential. So we can translate any of our curves translate means pick it up and move it. So let's do e to the x minus 2. So again, we're going to start. Will, not sure what you're doing, Angel. We're going to start with my base. This is my basic. This is my BFF that I memorized. This is 0, and this is the point 0, 1. So that whole shebang is getting dropped down 2. Aiden, same with you. What's on the iPad? What's on
checking the time.
Okay, well, guess what? There's a clock in the room, and we really don't care what time it is because we're in math land. We have a test coming up. So I'm going to take this whole thing, and I'm going to drop it down 2. All right? So this line is going to come down just like everything else. That's coming down. And that point is coming down. Everything's coming down 2 units. So the asymptote comes down, the point comes down, and then I can draw in my shape like I always do. All right, Mr. Stewart? All right. I can think of one, if no one has another one, I can think of one that is missed sometimes, and that's one where you have to find the asymptotes and holes, and we have a problem like this. Alright, and we have to find the holes and the vertical and the horizontal. Alright? So how do we start? Factor, anything that'll factor. So the top factors, x minus 1, x plus 1. What about the bottom? Pull a 2 out. So if I take a 2 out, I'll be left with that. If I take a 2 out, and then does that factor? X minus 5 plus 1. Uh-oh. We're gonna have a hole, right? So our problem becomes this now. This is our new problem. But we cancel, so we're gonna have a hole. Where, the hole is a point. It needs an X and a Y. Where does the X come from? What I crossed out. So this X would be a -1, right? How do I get the Y? Plug it in right here. So -1 minus 1. I'm plugging in -1. So -1 minus 1 over 2 times -1 minus 5. So that would be -2 over 2 times -6. Did you get 1/6?
Yeah, you get 1/6.
2 over 12, x -2 over -12. Now here's our problem. Do we have a vertical asymptote? X equals 5. Do we have a horizontal asymptote? Y equals 1/2. Okay, Mr. Stewart, before you leave, anybody who wants to take the test after school today may do that, okay? So if you would rather get it out of the way, you can take it after school today, if that's what you want to do, okay? All right, we have time for one more problem. So can you think of anything else? Tylen's your hand up? Nope. Sean?
Like the P, X, where you plug it in.
Okay, so a function composition problem where we have no numbers, where we're just doing it with the functions. So like a of x equals 2x squared minus 3, and b of x equals 5x plus 1. And we are going to find b of a of x. Okay? So we start right here. We are going to figure out what a of x is, and then we're going to plug it into the b function, right? So what is a of x?
2x minus 3.
2x squared minus 3. So we're going to take that, 2x squared minus 3, and plug it into the b function in place of the x.
So it's always going to be.
So 5 times 2x squared minus 3 plus 1. So 10x squared minus 15 plus 1, just doing my distributive property.
10x
And 10x squared minus 14. Don't factor it, don't set it equal to 0, don't do anything to it. Once you get like terms collected, just stop. Okay, Sean? And then we'll go the other way real quick, as this was the other order, and this is the last one, I promise. So those of you that are breaking out in hives, this is the last one. This says, take the b function, which is 5x plus 1, and put it into a.
So every time, you just put it in for the x.
Yes, just put it in for the x in the problem. That's right. So that would be 2 times 5x plus 1 squared minus 3. Okay? And then you would FOIL this out. This is a FOIL. FOIL that out. 5x plus 1, 5x plus 1. Then distribute. And then collect by term. That is your answer. Okay? So the inside one gets plugged in for the x and the outside one. Okay? All right. So, test on Monday unless you are coming in after school today. And if I don't have the extended times in my email in the next few minutes, you're not getting extended time. Get it done.
Can I take it during